Hello and welcome back to the Genesis Edge product line video series. My name is Charles Johnson, lead trainer and technical engineer at Lynxspring. And normally you see I have the about screen, but however, I want to continue. This is just a continuation from the Modbus export video that I did. So I had an Edge controller, an Edge 534. And I made that a Modbus device. So I added some points here. I'm going to get my control T on. Sorry. Went ahead and in my Modbus TCP slave network, I brought in a boiler and I have my control points here. And if we look, I've just got a little bit of logic here just to mimic, uh, mimic a just a working station here. So now I'm now back in my air handler controller, and now I'm going to be controlling the points of this hot water system. So we're going to enable the pumps based upon either a temperature, a drop in temperature, or or if the schedule calls for it. In addition to that, we're going to go ahead and switch the pumps based upon lead lag runtime and enable the boiler whenever the pumps are running. We are then going to control the hot water valve with a PID loop or a loop point based to maintain supply air temperature. So the first thing I want to do is I want to get a couple blocks in here already. So everything's going to be done in the kit control palette. And the first thing I'm going to do is I'm going to drag out uh, I'm going to drag out a loop point block. And I'm going to name this hot water PID. I'm going to drag out the lead lag runtime and just name it pump lead lag. I will also bring out a tstat block and just say OA temp enable. And then I'm going to go ahead and bring out a logic block. I'm going to do a logic OR. I'm going to name it pumps running. And now that I've got these out here, I can start with with my programming. So the first thing I'm going to do is I'm going to take this hot water pump status. This is very easy. And I'm going to go ahead and link this here to both of these. Why? One, it needs to start the boiler. Two, we use this as the feedback value of our pump lead lag runtime. And for those of you who are not familiar with the lead lag runtime block, what it actually does is that it takes the runtime or the discrete totalizer extension that we're going to be adding to these 2 points, and it looks at this runtime here based upon what output is running. So it's going to determine whether or not which one of these are on, and then switch based upon the runtime. Now, as far as my input here on my lead lag, I'm going to use our schedule that we have here in our controller. So I'm going to go ahead and take the current state, link mark, and go to link from, go to out of the current state into the in of the pump lead lag. Now this might go into alarm here, but that's okay. We'll go ahead and change that soon too. Okay, so the maximum runtime here, we're gonna go with 5 minutes for now, but obviously in the real world you'll want to put this at like a week. And the feedback delay, we're gonna go to 30 seconds here. And obviously there's nothing for the runtime just yet. So we're gonna go ahead and hit save here. And again, I can go ahead and clear this alarm, but I'm not going to right now because I don't have my discrete totalizer extensions here in my pump. And I'm going to use this OA temp enable for, I was going to do it for an override, but I'm not. I'm just going to go ahead and just bring in an and block here and just say OA temp, or we'll just call it pump enable. So I'm going to use this tstat block for whichever we are in. So if we're calling for it to be enabled, and we are calling for the lead pump as well. Go ahead and do out A. And then this is going to be another and. So we're going to say, actually, no, you know what? Scratch that. We are going to do this as an override. So go ahead and just delete that right now. So we'll get back to that tstat block in a moment. The second thing I want to do now is I'm going to go ahead and open up my kit control palette. I'm going to go to my extensions and go to my discrete totalizer. So with the discrete totalizer, I can determine what to actually count as far as what's been on or what's been off. This change of state count transition is whether or not it goes to active, inactive, or active or inactive. Of course, we only want to know when the pump has been running. So we're going to change this to change to active only. So I'm going to copy my discrete totalizer extension, and I'm going to go to my points here, and under my hot water pump command, I'm going to go ahead and hit paste, and I'm going to name this runtime total. And now that I have it here under my pump command, I'm going to go ahead and change this now to active. And since I've done that here, I'm going to go ahead and copy this and paste it into my hot water pump 2 command. Now, with this, I have no way to know the runtime here. I need to take the runtime from here and put it in here. However, it is not available for us. So if I go to pin slots, well, I don't see that here. Why? Because pinning slots only works with something that is inherently with a component. So all my slots here and all my actions are things that I can make available. However, if it's something that I've added, because the point is extendable, which means I've added an extension to it, I need to composite out the point. So again, I right click on my object and I go to composite. And from here, I expose the runtime total, and I'm going to expose the elapsed active time, not the numeric, but the elapsed active time. And I'm going to name it runtime. And I'm just going to bring out the reset elapsed active time. And I'm going to say reset runtime. And hit OK. So now we can see that my runtime is here. I'll go ahead and bring this here. And now I will composite this one out. And go to elapsed active time, again, runtime. And reset elapsed active time, reset runtime. Okay. Now, before I start linking all this here, I'm going to go ahead now and change my tstat a little bit. So with the tstat, I'm going to right click on it and I'm going to go to pin slots. And I'm going to expose the following. CV, which stands for controlled variable, set point, differential, and action. So that way I know whether or not this is going to be direct or reverse. For my OA temp sensor is going to go directly into my CV here. Now I don't have a set point though, and there wasn't one that we created in the Modbus controller, which we could have easily. However, I'm going to go ahead and create a numeric writable here and name it OA temp set point. I'm going to go ahead and change this to degrees Fahrenheit, and I'm going to set the fallback to 50 degrees. And now I'm going to bring this into my SP. I'm going to go ahead and double click my tstat now, and I'm going to set this up a few different ways. One, I'm going to set null on inactive, which means that if this pump or if this variable were to go to false, then I want to put out a null output. The reason why I want to do this is because when we're not using this block, I don't want it to control my point. And now I'm going to go ahead and set null on in control to false as well. And now for my differential, I'm going to choose 4, which means it's going to, this is going to take 2 up and 2 down. So pretty much here, this with the set point of 50, it will come on at 52 and go, or I'm sorry, I want it to go off at 52 and turn on at 48. Now, of course, if you want a tighter deadband, I do have another. You can use something called a hysteresis block. Though there isn't one in Tritium, we're going to be making one in a later video, and probably replacing this tstat with that hysteresis block. But for right now, we're going to use just the blocks in kit control. And now, as far as the action goes, direct or reverse? Well, if it's direct, means that if the temperature goes up, my output's going to turn on, and if my temperature goes down, my output's going to go down. However, when my input goes down, I want my output to turn on, which means now I'm going to select reverse acting. And I'm not going to change any of this right here. I easily could. Okay, so now that I know that my set point's here, if I wanted to go ahead and just turn this to 40, right, we can see now that it goes false. And I'll go ahead and set this to 50 again. Okay. And so right now it is true. So I could, in theory, create or something where I only run one of these pumps at a time. But I'm just going to go ahead and bring this into input 10 of each of my points. Okay. And it looks like I thought I changed this to active. All right, I did that. And then, yep, to active. Okay, I did. Fantastic. I'm going to go ahead now and clear the alarm state. And I'm going to take my output here and put this to input 16. And I'm going to take output B and put this to input 16. Okay, so now if I want to only have the hot water temp, the pump lead lag to run only, let me just go ahead and set my set point to something lower, let's say 38 degrees. Effectively, this is like a freeze protection kind of thing here. So right now, these points need to come on. We'll see why they are not coming on. And then we're going to take this here, this pump's running, and make sure that our boiler stays stopped. So this is also good troubleshooting as well for testing purposes. we can see that both that we've attempted to start this pump, but now the status it says stopped. So which means that that there could be a pump issue. It is also could be something where the value is not being written. So we're going to go in a moment and actually check that too. Okay, so now we've got this here. Let's go ahead and set up a control for our hot water valve. Well, we do need a hot water set point. So I'm going to go ahead and duplicate this and name this hot water supply or hot water temp set point. And I'm going to change the default to 170. So now for my PID loop, I'm going to go ahead and pin out some slots. The loop enable is 1. The control variable, the set point, we're going to put out the proportional, integral, bias, min, and max just to show and the ramp time. Okay, so when you're using a PID loop, I think of this as cruise control in your car. So you have you're driving and you are on the road and you want to maintain, 75 miles an hour. Well, you set the cruise control to 75 miles an hour, and the car will maintain 75 miles an hour. It will accelerate or decelerate to maintain that speed. The same thing applies here. Now, the proportional, constant, integral, derivative, I'm not going to go into detail about that, but we're going to set a couple things up. So we're going to go ahead and our control variable is going to be our hot water supply temp. Our set point is going to go into our set point. Our loop enable is going to go into pumps running. Uh, Maximum output, minimum output, I'm going to keep it 100, 0. For the proportional constant, I'm going to do, let's say we're going to do 20. We're going to do we're going to do 25 to start. And we're going to make this a reverse acting loop. And we're going to set the bias to 50%. And what the bias does is that this will output 50% when we are at set point. Let's go ahead and change the ramp time to 3 minutes. Again, I'm not going to change anything with the integral right now. I'm going to go ahead and start with the proportional constant and see whether or not whether or not the loop is going to work the way that I want, and then I will start to change the integral constant. So as right now, my output is true, and it's at 100% right now. So we'll go ahead and make sure that we, let's see, loop action, disable action, it should go to 0. Oh, my loop is true now. So it just took a while for my pump to get started. So this is just the value from the Modbus. So it is there. I'm going to go ahead and clear these alarms now. Okay, and now my boiler is also enabled. I'll go ahead and set this output to input 16 here. And I think that is all okay the way I want. Ramp time, 3 minutes. I'm going to change it to 5. Okay. 170, 25. Now we'll do this. Actually, we'll change the proportional constant to 20. Okay. All right. So I am okay, I think, with everything here. We actually don't need to go and troubleshoot. It just looks like it took a little bit of time for this to come up. We have added quite a few. We've added quite a bit to this 534 here. And I will eventually go over metrics of an edge controller as well for you guys to figure out whatever limitations you would like to have. But as right now, this is our Modbus device. Let's just go in there and take a look just to make sure that we can see things that are being controlled here. So go to my Modbus boiler here, and we see that we are constantly being logged out because of our user having still having auto log off enabled. Go ahead and disable that now. And now go to my Modbus network, my boiler, and my points, my control, right-click views, and go to AX Wiresheet. So we can see now that my pumps are being controlled, and my hot water valve is also being controlled at 76. So again, it's going to take a little bit. Modbus communication isn't the fastest, even through TCP. Actually, it's fairly fast. What kind of delay did I put here? Oh, that's why. This should have been 3 seconds and 5 seconds instead of minutes. And I will change that back here again in this Boolean delay. 0, 0, 3, and 5. Okay, that's why. So I don't know why I did that. So I apologize if you saw that in the video beforehand. But we've now corrected it. I was wondering why there was a lag. I didn't think it was going to be that bad, but it makes sense. It actually worked as intended. So yeah, we're going to, I think so far everything's all right. If I wanted to run this pump here now, if I go ahead and set the set point back to 50, now both pumps are going to run at the same time, and we should see the status change here very shortly. Let's see here. The status here does say that. Yep, we come back. It says running. Okay, great. So this actually concludes the logic portion of our Modbus boiler. So I hope you learned a couple things here today, and have a great one.